notation, so you could also apply it, because it makes sense now that we're kind of dealing with this. So again, you guys can see that we have the chain rule here. We have a outer function, which is cosine of x, and we have our inner function, which is xy. So instead of saying f of x and g of x, I'm just going to call the inner function u and say that's going to be xy. And then what obviously I know for finding the chain rule, I need to go ahead and find the derivative of this. So I'm going to do du over dx. So basically finding the derivative of xy with respect to x. So therefore, that's going to be 1 times y plus 1 times x dy over dx. And, well, it's basically derivative of y dy over dx times x. OK, so again, that's using some implicit on the inside. Notice again, I'm just taking the derivative of our u with respect to x. So therefore, I had to include that y dy over dx. And now we just go ahead and if we say my outside function is cosine d over dx of cosine of u. And d over dx of cosine of u, so that's going to give me derivative of u over dx. So now go ahead and taking my derivative of d over dx cosine of u. So my derivative here is going to be a negative sine of u. But remember, we have to plug in the inside function. So it's going to be negative sine of my u, which is really xy. And then relative xy, and then times the derivative, which is y plus x dy over dx. So again, remember this chain rule, derivative of our inside function, and then multiplied by the derivative of our inside function, which we said was our xy.